this class will only be partly recorded. I'm sorry. All right. Another important part of Python, right? Since everything is an object, everything you can put a dot afterwards and access its member functions, right? Anything defined on that class. So in PyCharm, if you say mylist dot, you'll get this helpful pop-up, and the pop-up includes all of the class functions, right? Methods defined on lists. So I can append things to lists. I can count items in the list. I can insert things into the list, right? And if you're curious what you can do with a ship, for example, as you play with the code, you can say ship dot and see what pops up, right? Or game board dot and see what pops up there. So that dot allows you to access the member methods of an object. And everything in Python is an object, including like these lists. Okay, so here's the answer to your question. Why would we start having more than one reference to a object? Well, you get a second reference to the object when you pass it into a function. So my list, this line here, this line creates a new object. When you pass mylist into this function, source list now points to that blue object. So anything you do in the function, you're using the name source list, right? But that location in memory is actually getting the side effects of your operations. So when you're back out of that function, even though source list is no longer exists, mylist now has a new value in location 0. Okay, we call this passing parameters by reference. So the changed list isn't getting the values 1, 2, and 3. It's getting a reference to somewhere else in your computer's memory that has those values 1, 2, 3. And so it's kind of dangerous, right? You're giving someone the keys to your house. You're like, hey, I have all these values in my basement. Here's the key to the basement. Just go check on them, right? And if you give it to the wrong kind of function, it goes and just murders one of the items in your basement, right? Or burns the whole house down, right? So oftentimes this kind of behavior is a source of bugs, okay? We don't like to write code typically that changes its parameters. It's much nicer to use the return of a function to pass back some information and say, hey, I didn't touch your basement, I checked on them all, and yes, they're all alive, right? Or no, they're all dead, right? Or the largest value I found was 100. Okay, there are sometimes functions that will write that will change their parameters, but we want to be very explicit that that's the behavior. Okay, so this is kind of what the why for delving into this in a little bit more depth. Okay, if we were to actually, you can find out where this thing is in your computer's memory by using the ID method in Python. And maybe I'll show you that once we kind of switch over to some code, right? But this is a memory location that points, the location of the blue object here. Are we tracking so far? Okay. So if you can point to things with variables, what happens when you point to nothing, right? So sometimes we'll find it useful to have a variable, but not to actually have it be active, right? To say, hey, you're actually not doing anything right now. You could point to something, but you're not. Okay, so to do that, we're going to use the none keyword. And here are 2 lines of Python showing how this works. The first line, as we've seen in several slides, that creates a new car. That creates the blue thing. That's the constructor that creates a 1 mile per gallon car, like the world's worst, most fuel inefficient blue car. And the same line actually initializes the myToyota variable to point to that same car. Okay? If I had omitted myToyota here and just said car 1, I would have gotten a blue thing in memory, but I wouldn't have been able to access it because I don't know where it went. It's like, go off and create a car, but don't show me where it is. Like, put it in the parking lot somewhere, but don't give me the keys. It's sort of a useless operation. So we're going to, of course, ask to get the keys back. Yeah, give me the keys to that new Toyota. Show me where it is. Right? But later on in my code, maybe I no longer need to use this Toyota, or I'll, again, this is out of context, so maybe this looks like a silly operation to do, but we'll see why this is useful. If I assign my Toyota the value none, that says disassociate this pointer from that object. Okay? And now the object is unused. So I've indicated that by sort of changing its color, right? There's no variable that can access this object, and it represents unused memory. And so Python's actually pretty clever. While it runs your program, it will be checking all the time, like, hey, I've got a lot of objects in memory. I've got chips, I've got players, I've got game boards. Are any of them dangling? Are any of them sitting out here with nobody pointing at them? If so, I'll go ahead and erase them from memory and mark that space as available for other programs to use. Okay? And this is actually one of the main reasons we don't use Python in embedded systems. Okay? Imagine that you're writing this code on a robot, and the robot's balancing a broom on its finger. This is a very clever robot. And it's got to have this fast twitch to like keep this pen right on the finger, yeah? It's going like this, and like this, and like this. And it has to do that maybe 1,000 times a second. But then you're running in Python, so rather than running your loop like it's doing, it goes, oh, you know what? Let's go ahead and check to see if any objects aren't being used. And this might take like up to a second. And meanwhile, your robot like not only has dropped the pencil, but its motors have caught on fire, and it's fallen down the stairs. We don't have any control over the garbage collector. It does what it wants. It takes as long as it wants, and in 99% of the time, that's great. We don't care. I want it to automatically clean. I want it to automatically clean up my system. Okay, and on a laptop, that's fine. My computer just froze for a second. Your computer freezes periodically. We go, it is what it is, right? And the garbage collector is running quickly. We won't actually notice it, but it will be a problem on an embedded system. Okay? Good. Thumbs up, thumbs middle, like things are getting a bit wobbly, or thumbs down, like things are not good today. Where are thumbs today?
Sir, could I ask a question about it?
Yeah, always.
I was just wondering if you were to then or I guess, is it possible to recover the data that you had previously associated with my Toyota, or is it just completely gone?
It's gone.
Okay, thank you.
Yep. No, I mean, again, at the lower level, we could peel back the hood of the computer here, and at the moment you say equals none, the only thing that's changed is that my Toyota no longer has that value, that location in memory. That location in memory, Paya, hasn't been used yet. But now it's marked as available. So the next time you create a list, or the next time a program wants to save some data, it could overwrite your object. But there's no way using the Python programming language to go and recover it.
Thank you, sir.
Mm-hmm. All right. It's actually, incidentally, the same way delete works on your computer. When you delete a file, right, you can delete a huge movie, and it's not like it goes and scrubs it and writes zeros across all those disk sectors. It actually just deletes the reference to that movie. And so that's very quick, right? It's very efficient. And but you can get in trouble if you want, somebody goes, do you have this movie? Like, was this an illegal movie that you downloaded? And you're like, no, I deleted it. Like, it's trivial to go back with forensics tools and find that sumption of ones and zeros that corresponds to that file still. All right. So, combining these two ideas, references, right? Multiple references and pointing to none. The first line of code here creates the car. This part of the line creates the car, and this part of the line gives my Toyota the keys to the car, say, right? A pointer to the car. Now we've seen this second line of code here several times. It kind of creates a copy of the keys, right? So now both my Toyota and other car point at the same thing in memory. Now, when I say my Toyota equals none, my Toyota loses its reference and no longer points at the car. But it's not eligible for garbage collection because somebody else, namely other car, could still be using it. Okay? And this is a finer point. We won't find this directly useful in our code, but I think it's important, like, for exams, right? So the way the garbage collector works is it counts the number of references to an object. So each one of these objects has a little data structure next to it, like number of references. And so this is 1, this is 2, and now it's back down to 1. When an object gets to 0 references, it's eligible to be deleted. Okay? And that's what garbage collecting means. And in a language like C, we'd actually have to go and clean up memory ourselves, and we had to do it all manually. And that's why C is used for robotics. I can schedule a time in my own code to go and deal with this stuff rather than having somebody interrupt this very critical timing loop and do it for me. Okay? So that's the end of the slides. Again, those are going to be available on the drive, so if you want to go back through that. Let's switch gears now and see how we can use these concepts in the lab. Okay? So go ahead and open up PyCharm. And let me clean up my code before I show it to you. Haha. Okay, and I want to look, we have 2 functions left to look at here. Place ships. Okay, and this is going to be a tricky one. And then, and the utilities draw ships. Okay, so both these functions we need to talk about. Now, let's remind ourselves of what these are doing and why they're here. Place ships is going to automatically create a valid configuration of a battleship, an aircraft carrier, a cruiser, a destroyer, and a submarine. You could imagine a more sophisticated version of battleship where we let the user drag and drop the ships and rotate them and all, but that's a mess, and so we'll just do it automatically. Okay? We'll talk more about how these objects relate to each other in the bigger structure of the program in lab on Thursday, but let me just show you the path here. When you create a human player, okay, then they are going to automatically place their own ships. We're not going to prompt the user to do it. We're going to do it automatically, okay? And so in this function here, I'm going to start, see the initialization here, the constructor creates an empty list of ships. It's my job to go through here and actually put the ships on the board, okay? Now, let's go ahead and just make up a ship location here. So self.ships.append. So this isn't a list, it's currently empty, and I want to put a ship on it. So let's go ahead and create a ship. And notice that I need to give it a length, the row and column of its bow, and whether or not the ship's vertical. So let's create, I don't know, an aircraft carrier that's somewhere in the middle of the board-ish. And, I don't know, maybe it's horizontal. Something like that. That's how we're going to create ships. Now, we can go ahead and create any ship we want. There's no restriction on these parameters here. Let's go ahead and give myself a wee little destroyer somewhere else on the board. And it can go ahead and be vertical. All right. So in this is how we create ships. Does it make sense so far? How do you know which kind of ships to make? that we should have a ship of length 5 and a ship of length 2? Well, that is simply defined up here. We're going to think aircraft carrier, battleship, destroyer, but the only thing the game needs to know is the length of each class of ship. And so the classic version of battleship has a ship of length 2, a ship of length 3, 4, and 5. So ship types is just numbers. So what I can do inside of this for loop is for each one of those ship types, make a ship. Okay? But for now, let's just put 2 ships on here, a big one and a small one, and go with that. Notice also that I've provided you with this debug function here. I'm not going to talk about what it does, but I want you to look at it yourself and figure out what's happening in it on your own. But if I get this place ships with the debug value set to true, I'm going to print this thing out. I'm going to run this code here. So that's called in the main function here. Right? We're going to start drawing these ships. But the human is the one who places them. So if you go to the human.py file and say place ships, the default is false, but I'll say debug equals true. Now let me go ahead and play my game. Let's see. Now the debug function is not going to work until we do a bit more tricks here. So let me pause on that. Now we've got these ships, we don't see them, right? There's this difference between what we stored in memory. We've created these ships, but I now want to show them to the user somehow, and I want to paint them onto the screen. So I would start by doing the paint function here. So let's just try this out. We'll go to the utilities here. And what do I get? I get a game board and I get a set of ships. Okay, let's just pause here and see what this looks like. I put a breakpoint in my code. And now I'm going to use the debug tool, so the bug instead of the play. I'm going to run this. And now I've paused at this line of code here. Let me just move that out the way. Okay, and notice that I've got these ships here. There are 2 ships, of course, because I only created 2 ships. And you see I've got a column, whether it's vertical, it's 5, it's 3, right? I've got these ship data structures. I want to use this information in order to paint sprites onto the screen. Okay, so I want to take those images that I cut out of the sprite sheet and cut and paste a bow symbol and a ship body and a stern symbol together to show you where these ships are on the game board. Okay, so in this utilities function, I should be looking at the sprites, and I should be blitting the sprites onto the board. And the way I know where to put them is because of this ships array here. So let's just try to draw the bow of each ship. So for ship in ships, and then I'll do this little print to make sure that I'm doing the right thing. Ship.row, ship.column. Okay, so let's go ahead and we can stop our game and play it again. And you see bow is at 3.4 and bow is at 6.6. That should make sense. Don't worry about how we got into this function. We'll talk about the wiring of it all. But convince yourself that if you create a ship in the place ships function and put it in that ships array, then by the time you get called in this function, what you're getting are those same ships. So where should I place the sprite for the first ship? The bow sprite. Brooklyn. I've got it highlighted right there.
So we just put it at 3.4?
At 3.4. Now, Now, is it at pixel 3 and pixel 4? I mean, that'd be right up in the top left corner of the screen, right? That's block 3 and block 4. See that, right? So if my blocks are 30 pixels wide, I can figure this out. But then there's a header row, right? There's a translation somehow between that 3, 4 and the actual pixels where I want it, right? So we could stroke our chin, but we did the pixel math already last week, and I don't want to bore you with geometry too much. So I've given you a nice little function inside GameBoard, a member function of GameBoard. So let's try that out. Let's say board dot. Okay, and then we look through here, and what is a? Let me change my window capture method here. Let me do this. My board dot, and you see, is there a function here that popped up that might be useful? Like maybe that one.
Add sprite.
Add sprite. Well, let's just try that out. Sprites dot, right, and now you should have the sprite sheet cut out for the bows and things like that, right? I haven't actually finished that part yet. Ooh, I should have done that, right? Let me just give myself a quick little one here. So ship top, right? 3030. And then the rect for that is going to be incorrect, but you can put the right values in here. Right? So we're going to make a ship top, and we're going to spin ship top here. But now when I go back to my utilities here, sprites dot ship top. Okay? And then the location. And this is where I've given you a little bit of a break. I can pass a location in as a row, comma, column. Ship.row, ship.column. How does that work? Well, in GameBoard.addSprite, it's very simple. It just multiplies the XY that you gave me by the X step and adds 1 because of that header on the row and on the column, right? So you could have done this, but that's tedious to always remember how to do that. So I'm just doing the multiplication for you. That makes your code a lot easier to read. Okay? So now, when I run my code, you see I've got a bow sprite. I mean, it's wrong. Don't. That doesn't look like a ship. I cut the wrong part out of my coupons, right? But yours will be correct. But it depends. You be using the ship top sprite or the ship front sprite. It depends on whether the ship's horizontal or vertical. So maybe you need an if statement in there. All of the pieces that you need to assemble the jigsaw pieces are in these ship objects. Okay?
You would say, what did you run to check that? Did you run main?
Yes.
Is there a stop in your main, or is it the full main?
A stop. No, this is the full thing, no breakpoints.
Because I'm getting like an error when I run my main. Coming from the one we modified with like the append ships.
Make sure that, our syntax is correct here and everything. So, in player state here, I just created 2 ships here. Make sure
would you also be able to go back to the ship, the sprites one for like the ship top?
Yeah, now this I was hoping you would have done over the weekend. Fine, I got it. It's not Wednesday night yet, but you're just going to go through the part here that you need to work on is figuring out these pixel coordinates to nibble out these sprites correctly. Right? This is the top left of the message box. All right?
Oh, got it.
So you can, good, work on the draw ships code, even if you don't actually know how to randomly place ships on the board yet. Okay? You can work on these kind of independently. If you want to work on this code first, what you can do in player state is just create some ships. They don't have to be the normal size. You can create a ship that's like 6 long. I don't know. It doesn't really matter. In the utilities function for shipping ships, you're gonna have to figure out how long is this ship. Is it horizontal or vertical? And that depends on what row and column I want to stick the bow in, and then I want to march down. Think about it, right? There's like a little bit of kind of arithmetic we need to do to figure out how to build these ships up. But what I don't want to see is some kind of weirdly sliced apart ship that looks like it went through a teleporter the wrong way, right? Where the bow is poking into the stern and I've got gaps in the pixels and stuff like that. Okay? So that's kind of an artwork function and a bit of bookkeeping. The player state, in order to randomly generate these values rather than statically doing this, okay, that's going to be tricky. Here's a technique. What if we go through and randomly find some values? The length is going to be given to us, right? We know I want a 5, a 4, a 3, 3, and a 2. But I can pick any row, column, and any orientation. So what I can do is randomly pick values for these 3 parameters, build out 5 ships, and check. Is that valid? Like, did I happen upon a valid board? Right? And if I did, then I'm done. But if somehow my aircraft carrier is on top of my destroyer, then that didn't work at all. Okay? So I need to figure out a way to check whether my board is valid. And the way to do that would be to have a view in memory of the game board itself. Like, this is like a matrix. Okay? And once I place a ship, we should mark that spot is taken. Okay? And that way, when we randomly place a ship, we can say, hey, are you going in a set of spots, contiguous spots that are all available? If so, great, you stay there. Otherwise, let me randomly jiggle your parameters, throw the dice, and try it again. Okay, so how do we represent this kind of data structure in memory? A matrix that's going to have empty slots where there's available spaces. Well, what we could do is have 100 variables all pointing to nothing. And once I place a ship, I could take all the variables that occupy ship spaces and point them at that same ship. Okay? And when I want to check whether a ship is in a good spot, I can find all the variables that represent its location and say, are you all pointing to none? Great, you're all pointing to none. It's good. I can stick you right there. So what I've done here is created this board matrix variable. Okay? And it's a little tricky. I will give you that. But
Can I ask you a question about the...
Oh, yeah.
Will we be reusing the same thing to check if you're hitting something with your guess? Or is it a different method?
It's going to be different. For checking whether... So once we've placed the ships, once these ships are part of the player, we can then have a function isHit, which goes for ship and ships, and we can actually ask the ship itself, hey, ship, are you hit? Because the ship knows where its bow is, it knows how long it is, and it knows its orientation. So if you give it J6, it can figure out whether it's been hit. We actually don't need the 100-element matrix anymore.
Yeah, that makes sense. Okay, thank you.
But we could use it to, for example, check double guesses, right? So we'll see how it evolves, but let's not get too in the weeds there. So board matrix, we don't really need to know much about this. It's called a list comprehension, this syntax here, but it creates a 10 by 10 data structure, all of which point at none. All the elements in here point at nothing. Okay? Initialize all the values to none. There are no ships on the board. Okay? What I can do is then take this ship here, and how would I represent that on board matrix? If this was actually my ship, what would I do to board matrix? I would say board matrix, and where's its bow? At location 3, 4, right? And let's just say ship 1 equals ship. So I'm putting one pointer to that thing in the ships array, and the other, I'm taking that same blue object, that same car, or whatever it is, a ship now, but these two different variables are pointing at it. Board matrix 3,4 is pointing at it. What other, and so let me stop this and play it again. Look at my debug printout now. I've got a single 5 hanging out here. Notice that. No. Let's hide it. What other spots in this 100 by 100 or 10 by 10 matrix should point at ship 1? It's a horizontal ship, okay? So it should be, its row should stay constant, but its column should change, right? You see this? All of these elements in this structure are pointing at ship 1 now. There are 5 blocks for this ship, and so to use this technique, I need to go through here, right? And set them all up. Okay. And there you see, this is actually a representation of the game board in text. I could do a representation of the game board with graphics, which users prefer, but this is a way to print out the game board using text. This is a 10 by 10. It's rectangular because of the aspect ratio of the font, but this is 10 wide, 10 high. And I'm using the ship length here as the character to sort of visually display this aircraft carrier. So then to use this to check whether my second ship is valid, what I would need to do is say, make sure all the spaces are currently set to none, right? So if board matrix 6,6 is none, right? Then we're okay. So then board matrix 6,6 should point to what? What should I set it equal to? We'll call this ship 2, right? So what should I set line 52, board matrix 2? What are we thinking, Paul? All right, Paul, I picked on you already. You're in my top right corner, so I can only see you. But Maria, what do you think? I want to reserve.
Ship 2.
Good, yeah. So I want to reserve a spot on this board matrix and say it's now occupied by ship 2. Okay. And so now we see in my little printout here, I'm starting to see the second ship pop up. Okay, so it's up to you to figure out how to put this together in a set of loops, and maybe it's a while true that you break out of once you figure it's all set, or I don't know. There's different ways to go about it. But board matrix is your tool to check whether your proposed ship location is valid. And if you decide your proposed ship location is valid, the way you store that information is by appending the ship into the ships array, and also pointing, setting all those locations in that 10 by 10 structure, pointing them at that ship. Okay? And if you do that correctly, you should be able to see on the debug when you say, remember, go to human.py and set right, and say debug equals true. You should see this printout displaying a valid battleship board. And the other thing, now there's one other thing we need to think about when we place ships randomly. All right, they can't collide with each other, and that's what our board matrix is going to tell us. Right, that's going to detect collisions. What other problems would a cheater like myself try to do for battleship?
Make sure they don't run off the edge.
Yes, yes. One of my favorites is the carrier that's hanging off into the nether, right? That's a Minecraft term. So the my son is super into this game, and it's really gotten to me. But we want to make sure.
Sir.
What's that?
I was saying it's completely your son, not you, sir.
So the second thing we'll want to check is to make sure that all of the ships, their sterns don't hang off either the bottom of the board or the right side of the board. That we can find that out by making sure, we start at the bow, right, gives me the row column of the bow, and they'll increment, +1, +1, +1. If I get to the stern and I'm at location 10, I've gone too far. The valid locations are 0 through 9. 0 through 9, 0 through 9. Okay? The user, the poor human, God, humans are the worst, right? We're going to give humans the idea that the columns are numbers and the rows are letters, right? But really, they're both numbers. It's just the way Battleship has evolved from Milton Bradley is that we call it B9, right? Rather than 1, 9, right? So we're going to start with 0, go to 9. And we'll see when we start doing guesses and we deal with the human, we'll do that translation. But inside this function here, inside place ships, deal with the numbers 0 through 9 for both the row and the column. Okay? And I think that brings us to the end of the class. Work on this now so that tomorrow or Wednesday when we have class, you can come with your questions. I'm happy just to give you another lecture and talk more, but it'll be much more useful to you if you're stuck on a bug to say, hey, here I am in the middle of my place ships function and it's just not working, right? So please be proactive, start this lab. It's hard. It's a hard one. And if you have questions before lecture on Wednesday, don't hesitate to email me and I'll try to get to it, okay? Good. Well, good luck. All your grades should be back from Lab 1. Everyone did a great job. I like it. And like I said in the beginning of class, please check out that video, if only while you're like munching on your lunch or something, for the solution, just to see some other techniques of writing Python. Okay, good to go.
Would I be able to show you my code for a little bit? For some reason,
Sure. Yeah, so if you're done, go ahead and head out, and I will talk to you on Wednesday. If you'd like to stick around, stick around.
Thanks, sir.
Hey, thank you. See ya.
Sir, do you mind if I share my screen?
Yeah, that's good. Let me make sure I enable it. Sometimes it's... Okay, you should be good.
Okay, can you see this, sir?
Yep.
Okay, so I think I tried to run main, and I got this error.
Sure, indentation error. Okay, so that's easy. Line 57. You can actually click that blue. It's a link to the error. Okay, so here, just make sure that your indents are all structured correctly. Although, maybe scroll up a bit. There we go. Ship 1, board matrix. Self-that ships that append. Ship 1. Okay, so line 53 here, you've got a question mark, right? If statement, but nothing underneath. So if you want to stub that out and not have anything there, you got to put the word pass, P-A-S-S. Okay. And that means don't do anything. Yeah, but that allows Python to understand the indent structure, and that the next line, line 58, is outside of the if statement.
Okay, and then also for getting the debug to work, so you would go in here and you put in something here, right?
True. Just put the word true, yeah.
So just true.
Mm-hmm.
And then also there's one more spot you have to go in, like, not here. Is it here?
No, that should be it, yeah. So that's just the, yeah.
Okay.
Yep.
So now if I run it from main,
Uh-huh.
it'll show up here.
So you'll want to make sure, let's see, line 73. Yeah, click on that. Okay, so you put something inside of ships which isn't a ship, right? So let's go back up, scroll up here. Ship equals, look, line 39 and 48, those aren't actually ships. Those are lists. You just gave me a list of numbers. Turn that into a ship by putting the word ship in front of that. And then it turns into a constructor that makes a ship.
Like that. Like that? The big
Yep.
ship?
Yep, the capital S there. So that's going to create a new object in memory, and then you're going to be able to point to it with different variables.
Okay, yep.
All right?
So I got this.
Yeah, look at that. Okay, now you just want to...
That seems a little weird as that, right?
Sure, so go back to the way you've written your code. So in the place ships function.
That's here.
Right.
I did 4.
4 or 5, yeah. And then in the draw ships, you want to take into consideration whether it's horizontal or vertical in order to get the right bow sprite.
Yeah. So that's...
So that'll be in the draw function, utilities.
Oh, yeah. So here.
Yep. And then rather than board.add sprite, you would say if ship.isVertical, right? Board.add sprite ship top.
Would you do a if is vertical and then a for that, and then another if it's not, or like an else for top?
Well, so you'll want nested for loops certainly, but we want to go through each ship one time. So line 21 is unchanged, but below line 21, inside this loop, now that we've got a ship, all right, we want to start at its bow. So bow.add sprite is good, but we don't know whether it should be sprites.ship top or sprite.ship front.
So the bow is right, so then you do if, and then you do like is vertical.
Yeah, if ship, right? Lowercase ship, because then we have a particular ship in our hand.
Right. Yep.
Dot, yeah. And you see that is vertical pop up. Mm-hmm.
Equals true or no?
But I mean, you say double equals true, but certainly we can say colon there, right? If ship dot is vertical, we don't have to.
Okay. We don't even need that.
Right. You can say colon, and then tab that out. Else. Right. So that's when you want the ship top sprite, and so you want to indent.
Tabbed in, right, and then else.
Indent line 24. Yeah. Else board.add sprite. Same coordinates, same ship.row, ship.column, but a different sprite. Sprites.ship front.
Which one did you say would be?
The front sprite. Now you'll have to have cut that out and done the sprites.py file already.
That's in here, right? I did them, but is it the right one?
Ship. Oh, sorry, I'm mistaken. Ship left, right?
Ship left. Okay.
Yeah.
Okay, that makes sense. So that's how they are doing it. Is vertical. Would you do another thing for like depending on the lengths? Could you do like ship is like a carrier or something like for ship dot carrier?
Well, there's no concept of carrier or battleship here. We only have the idea of length. So we're punting a little bit by saying, oh, all our graphics are the same, right? But what you'd want to do is place the bow, and that depends, right, on the ship orientation. And then we might have a for loop, like for block and ship.length, right? Start adding like chunks of ship. And then the stern, we also have to make sure that we do the right kind of stern. But it's coming together, right? You see how the puzzle pieces are getting put down?
Yeah, that makes sense. So there would be one going like here, you can see it, and then it would be like another bottom would be right here. All right, thank you. That's good.
All right, cool. Well, now if anybody watches the whole lecture video, they'll get a little bit of a hint for the lab.
Appreciate it, sir.
All right, have a good lunch. See you.